Today you will be integrating exponential functions. You may remember that the derivative of e to the x is e to the x, and that the derivative of something like e to the x squared, we'd need to use the chain rule, so that would be e to the x squared times 2x. Well, the integral works the same way. If you wanted to integrate e to the x, we get e to the x. And you may also remember that the derivative of a function like 5 to the x is 5 to the x times the ln of 5. Or if it was something like 5 to the x squared, that the derivative would be 5 to the x squared times the ln of 5 times 2x. So it follows that if you wanted to take the integral, let's see, of a to the x, that you'd be left with e to the x, except instead of multiplying by the ln of the base, you'd be dividing by the ln of the base. Now you have about 9 problems on your worksheet to do. I'm going to work them all out here, but I suggest that you pause the video and try each one on your own before you start watching the solution. So number 1, now this is not just e to the x, so we need a little chain rule. So du is 3 dx, so we need a 3, and we're going to cancel out with a 1/3. Once we substitute, we're going to get e to the u du, and the integral of e to the u is e to the u. So that's 1/3 e to the 3x plus 1 plus c. Number 2, is again a u sub problem, where du is negative 2x dx. So what we need is a negative 2x. So we'll need a negative 5/2 on the outside. Now we substitute. We've got e to the negative x squared, which is now e to the u, and negative 2x dx is du. The integral of e to the u is e to the u, and then we substitute. So we've got e to the negative x squared plus c. 3. All right, let's let u equal that exponent once again. Then du, let's see, this is x to the negative 1. So du is negative x to the negative 2 dx. So why don't we rewrite this so that it's e to the 1 over x, x to the negative 2. And we need that to be negative x to the negative 2. So let's just adjust those there. We'll have negative on the outside, e to the u du, which is negative e to the u, or negative e to the 1 over x plus c. Okay, 4. Again, we'll let u be equal to the exponent. We need a negative sign. So we've got negative e to the u du. So negative e to the cos x plus c. Number 5. Now we've got a definite integral over here. So all right, we've got our u sub going. We need a negative. We'll cancel it out on the outside. So we've got negative e to the u du, but we have to change our limits. When x is 0, u will still be 0. But when x is 1, u will be equal to negative 1. Now we don't have to do this, but I think it makes it a little simpler. See how the larger number is below? Let's switch those, and then we don't have to deal with the negative out in front either. So we integrate e to the u, we get e to the u. We substitute e to the 0 minus e to the negative 1, and that's 1 minus 1 over e. Number 6 is another definite integral. We're going from 0 to 1. Okay, this time our exponent is just x. So let's try, oops, I don't mean that. Let's let u equal 1 plus e to the x. Then du would be e to the x dx. So notice that we've got du right here. Here's our e to the x dx. And we're left with 1 over u. We have to substitute our limits here. Let's see, when x is 0, that would be 1 plus 1, so that's 2 down here. And when x is 1, we've got 1 plus e. Okay. We know that the integral of 1 over u is ln u. Now let's substitute that stuff in. Let's see, we got ln of 1 plus e minus the ln of 2. Number 7, we're going from negative 1 to 0 of e to the x cos e to the x. So let's let u equal e to the x. So this here, e to the x dx, that's our du. So we've got cos u du. And let's see, what are our limits? We plug in negative 1, and we're going to get e to the negative 1. And then e to the 0 is 1. Now we integrate, we're going to get sine of u. And that becomes sine of 1 minus sine of e to the negative 1. Okay, number 8. We're integrating 3 to the x. No need for u sub here. This is just going to be 3 to the x over ln of 3 plus c. But 9 is a little bit different, our last one. We've got x times 3 to the x. Oh, that's 3 to the x squared. So now we'll need our u sub. We'll let u equal x squared. Du is 2x dx. we need a 2, and we'll cancel that out with a 1/2. So we have 1/2 times the integral of 3 to the u du. So that's 1/2 of 3 to the u over ln 3 plus c, and now we want to substitute so that we've got in our numerator 3 to the x squared over 2 ln 3 plus c. And if you feel like getting fancy, we can make that 3 to the x squared over ln of 9 plus c.